So today we are going to do a really lightning quick lesson on radians in the unit circle. And you may remember radians from last year. They have to do with dividing the unit circle up into different values of pi. Radians are really based on the circumference of the circle. The circumference of the circle, if you'll remember from last year, is found by doing 2 times pi times radius. Well, in the unit circle, the radius is equal to 1. So you're really doing 2 times pi times 1, which is just equal to 2 pi. So that means if this is your unit circle, and you start here at 0 and take a walk all the way around, that this right here would be equivalent to traveling 2 pi units around the circle. Okay? And that means that if going all the way around is equivalent to 2 pi, then going halfway around is equivalent to 1 pi. And that's important because radians are all based on fractions. And when you say, a third of pi or a fourth of pi, remember that when you're talking about pi, what you're really talking about is half of the circle. Okay, so this is like your pi. Imagine the pizza guy came and delivered you a pizza that only looked like half of a pizza, but that was considered to be a whole pizza. Okay, so when we're talking about dividing pi up into multiple pieces, we're really just dividing up the top half and then making pieces that are that same size down on the bottom half. So even though we're putting numbers all the way around the circle, it's all based on dividing this top section up into pieces. Okay, so what you're looking at here is basically 4 copies of the same unit circle, and we're going to divide each one up separately, and then I want you to see what it looks like all completed. So it's up to you if you want to try to fill in your blank copy of your unit circle, which, by the way, that's found in your notes packet. We filled in one full unit circle already, but on the back of that page you would find a blank one. That's what you're filling in as your notes today. You can fill it in as I go through these 4 separate ones, or if you want to wait until the next slide, I'm going to give you one total completed one that you can copy down. Okay, so I've got all of these circles divided up into just pi and 2 pi. Let's suppose in this first circle, I then divided this in half. So really what I'm doing is cutting pi, because the top half of the circle is pi, in half. That means I would call this pi over 2, because it's half of pi. And then I could say, so this is pi over 2. If I went for the second half, I now have 2 pi over 2, which you'll see is really equivalent. 2 pi over 2 is just the same as pi. Okay, and if I made that same cut down below, this would now be 3 pi over 2, and then over here this would be 4 pi over 2, because here I would have, this would be 3, 1, 2, 3 pi over 2, and then if I add this one in, I would now have 4 pi over 2. And 4 pi over 2 is equivalent to 2 pi. Okay? So that's dividing it up into halves, into pi over 2's. Okay? For my next one, I'm going to start with that same cut in half line. Okay? But I'm going to now take those halves and cut them in half. Notice I'm just doing it to the top first. So now what I really have is pi divided into 1, 2, 3, 4 pieces. So now I would call this pi over 4. This would be 2 pi over 4, which really lines up with this, right? Pi over 2 and 2 pi over 4, that's really the same thing. This would be 3 pi over 4. And then this would be 4 pi over 4, which again, 4 pi over 4 is really just the same as pi. Okay, I put those in though just so you can see how it kind of corresponds, how that pattern works all the way around. By the way, this top half of the circle is equivalent to 180 degrees, right? So pi is equivalent to 180 degrees. So if I took that 180 degrees and divided it by 4, if I divided it into 4 pieces, it would make it so that each one of these angles was 45 degrees. So this is 45, this is 45, this is 45, and this is 45. So these lines that I drew, these ones, are going to that middle dot in each section. If I continued making those same cuts down here, if I were going to draw to the middle dot on the bottom half of the circle, I could keep that pattern going. So I went pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So this here would be 5 pi over 4. This here would be 6 pi over 4, which again, 6 pi over 4 is really equivalent to 3 pi over 2, and those are in the same spot. This would be 7 pi over 4. And then this would be 8 pi over 4. And 8 pi over 4 would reduce to 2 pi. Okay, starting over with a fresh circle down here. Again, I've got pi on that top half. If I took pi and divided it into 3 pieces, here's what it would look like. Okay, so now I have 1, 2, 3 pieces of pi. Pretend all 3 of those pieces are the same size. And so these markings would be pi over 3, 2 pi over 3, and 3 pi over 3. Okay, and again, we could figure out how many degrees that is, because this is 180, right? And if I took 180 and divided it into 3 pieces, each piece would be 60 degrees. So this is 60, this is 60, and this is 60. Which means this first line that I drew here would go up to like that third dot in the quadrant. Remember, you have like 30, 45, 60. This is the 60 degree mark. Notice this one skips over the 90. It does not include this line here. Okay? It goes 60 degrees past this one, which would actually be 120. So this is at the 120 degree mark, and then this would be at the 180 degree mark. Okay? So it's every 60 degrees I'm cutting. And then I could do those same cuts down here and here. Oh, again, pretending those are the same size. Continuing my pattern, I had 1 pi over 3, 2 pi over 3, 3 pi over 3. So now I would have 4 pi over 3. This would be 5 pi over 3. And then out here, this would be equivalent to 6 pi over 3, which 6 pi over 3 is really just 2 pi. I don't ever really call this point 6 pi over 3, just like I don't really ever call this point 2 pi over 4. I name them with the most reduced simplified fraction that I can, but it's just helpful to see how that corresponds going from circle to circle depending on how you're cutting it. Okay, for this next one, I'm going to start with those same 60 degree markings that I had a second ago. Okay, oh, that's a little better. So this is really, again, pi over 3 and pi over 3. Okay, so this is cut into 3 pieces, this is cut into 3 pieces. But now I'm going to take those thirds and cut each one of them in half. So it's going to look like this, and like this, and like this. And remember, we're really just focusing on the top half as being one whole pi. So this now took that one whole pi and divided into 1, 2, 3, 4, 5, 6 pieces. So now each one of these pieces is a pi over 6. So this is the one that gets really messy. Oh, I can't. Thought I could maybe move that out of the way. I might just use a different color on this one so that it stands apart a little bit more. Let's go with some green. So we said this was dividing into 6 pieces, so this would be like pi over 6. This would be 2 pi over 6, which really corresponds with the pi over 3 over here. Okay, 2 over 6 and 1/3 are the same thing, so that's at the same marking. This here would be 3 pi over 6, which again, that 3 pi over 6 is really the same thing as the pi over 2 we had up here. 4 pi over 6, which is the same thing as the 2/3 from over here. 5 pi over 6. And then this single pi would be 6 pi over 6, which again, 6 over 6 just reduces to 1. I could keep going, and this would be 7 pi over 6. 8 pi over 6, which would really be the same as 4 over 3. 9 pi over 6, which is the same as 3 over 2 from up here. 10 pi over 6, which is the same as 5 over 3. 11 pi over 6, and then this would be 12 pi over 6. So this one has a lot going on, but there's a lot of those angle measurements that are really equivalent to something else, so you wouldn't necessarily list them individually. Just wanted you to see how that worked out. By the way, your angle markings here would be if I took 180 degrees and divided it into 6 pieces. 180 divided by 6 is 30. So each one of these marks is 30 degrees. Okay, so if you're cutting every 30 degrees, you're going to cut at 30, you're going to cut at 60, you're going to cut at 90. Really, you're cutting everywhere except the 45-degree line. So you're cutting everywhere except like what these lines were up here. Okay, these would be like the middle lines that are coming down in between the 30 and the 60. Okay, all right. Now that we've kind of seen where all of those numbers come from, I'm going to put up just one finished example of radians on the unit circle that has everything on it. And that's what I would like you to copy down, and that's what you should be using to practice with. So, like I promised, here is a fully filled in copy of the unit circle, okay, with radians. And notice the fractions I have listed here are just the most simplified versions of the fraction. So I didn't put like 3 pi over 6 here or 4 pi over 4 here or anything like that. So this is just the most basic version of the fractions that should be on there. It may be helpful for you to put in your degrees, at least in this first quadrant. This is 30 degrees. This is 45. And this is 60. And I like this picture because they use 2 different colors to kind of show you the 2 different sets of cuts we did. I did 4 different circles, but really I could have done 2 different circles. One would have like the 90 degrees and the 45 degrees on it, and then one would have all the 30s and 60s on it. That's what the 2 different lines represent here. So if you need to, pause the video at this point. Make sure you get this copied into your notes, and then there will be one more short lesson on how to convert back and forth between degrees and radians.